Good morning to respected dignitaries and members of faculty. Warm welcome to a one-week faculty development program online on electric vehicles, technological advancements and trends from February 20 to February 25th, 2023, organized by Vasireddy Venkatadri Institute of Technology from EEE Department in association with II Students Chapter. Welcome to the 7th session of FTP. Dr. S. Albert Alexander is the recipient of prestigious Raman Research Fellowship from the University Grants Commission, Government of India. He is a postdoctoral research fellow from Northeastern University, Boston, Massachusetts, USA. His current research focuses on fault diagnostic systems for solar energy conversion systems and smart grids. He has 15 years of academic and research experience. He has published 57 technical papers in international and national journals, including IEEE Transactions, IET, Elsewhere, Taylor, and Francis, Ville, etc., and presented 53 papers at national and international conferences. He has completed 4 government and India funded projects, and 4 research projects are ongoing with the overall grant amount of rupees 2.3 crores. His PhD work on power quality earned him a national award from ISTE, and he has received 25 awards from the Meritorious Academy. Gujarat Best Researcher Award from IEEE Madras Section, etc. He has also received the National Teaching Innovator Award from MHRD, Government of India. He is an approved Margadarshak from AICTE, Government of India. He is the approved mentor for change under Atal Innovation Mission. He is an AICTE approved translator under National Education Policy to translate engineering books into regional languages. He has guided 32 graduate and postgraduate projects. He is presently guiding 6 research scholars, and 5 completed their PhD under his guidance. He is a member and in prestigious positions in various national and international forums, such as Senior Member IEEE and Vice President for Energy Conservation Society India, etc. He has been an invited speaker in 250 programs covering 9 Indian states and also at USA. He has organized 13 events, including faculty development programs, workshops, and seminars. He completed his graduate program in electrical and electronics engineering from Bharatiyar University and his postgraduate program from Anna University, India. Formerly, he worked as a professor in the Department of Electrical and Electronics Engineering, Kongu Engineering College. Presently, he is working as Associate Professor in the School of Electrical Engineering, Vellore Institute of Technology, Vellore, and also doing research work in artificial intelligent controllers, smart healthcare systems, smart grids, solar PV, and power quality improvement techniques. He has authored the following books in his areas of interest: Basic Electrical Engineering, Khanna Publishers, under AICTE, Government of India; Design and Simulation of Electrical Machines with MATLAB, Nova Publishers; Power Electronic Converters for Electrical Vehicles, CRC Press; Power Electronics Converters for Solar PV Systems, Elsewhere; Advanced Deep Learning for Engineers and Scientists, Springer; Computational Paradigm Techniques for Enhancing Electric Power Quality, CRC Press; Basic Electrical, Electronics and Measurement Engineering, Anuradha Publishers; and Special Electrical Machines, Anuradha Publishers. It is my privilege to invite such a noble personality, our chief guest, Dr. S. Albert Alexander, sir, to start the session.
Just to share the uh, organizer tool for me to share my screen, please.
Hello, sir. We have
Yes,
a
sir.
permission. Sir. You can directly share this screen, sir.
Okay. But here I'm not having. Okay. Okay, sir. Okay. I got it. I got
Yes.
it. I got it.
Yes, sir.
Thank you. Thank you.
Good.
Okay. Okay. So whether my screen is visible, sir?
Yes, sir. It is visible, sir.
Okay. Now we're making it as a slideshow. Okay. Fine. Okay, so good morning to one and all present here for this session number 7. Okay, so it is indeed a great pleasure for me to talk in front of you regarding this power electronic converters for the performance improvement in electric vehicles. And I sincerely thank the organizers Luke J. Bhakta Singh sir and Suresh Kumar sir and all the organizers who are the organizing committee for inviting me to deliver this lecture on this power electronic converters for the performance improvement in electrical vehicles. So let us move on to the session. So before moving on to the session, let me give two inputs. That is, if my voice is breaking or if my slide is not moving, you please interrupt me. And also, if you have any questions, even at the middle, you can please put in the chat box or you can be able to interrupt even at the middle. Okay. So thank you so much. So before we move on to this particular session, my objective is what are the various converters can be useful for the electrical vehicles. Normally, when we talk about the converters, we normally talk about only two different types of converters. One is either a chopper circuit or other maybe an inverter circuit in the power train. Okay, so many people are doing the work in this particular area. Okay, that is, they will be using the chopper for the DC to DC conversion when the power train is powered by a DC to DC, and whenever you're going to give the connection to the motor. Okay, so we normally give the DC to AC conversion with help of inverter. So under this particular topic, many papers have been published and many peoples have been done in this particular area. If I am also taking the same thing that chopper is useful for DC to DC and inverter is useful for DC to AC means it will be like a normal content. So I want to give some additional inputs related to this area. That is what works which I am doing in this particular performance improvement in EV. Okay, so this is the normal version. So I am working on the area of designing the controllers. Okay, controllers. Okay, for the performance improvement. So the converters plus the controllers will make the improvement of my performance. So here we work across the different set of controllers. Okay, so taking the feedback from the output and giving the inputs to my switches, that is a desired pulses, we are working on to that. So here we normally, even though we are having the four different types of converters are available in the power electronics, we completely rely on only the choppers and inverters for this electrical vehicle based study. We normally reject this rectifiers and also the AC voltage converters or cyclo converters in this particular area. So we focus on this choppers and this inverters. And many people are doing some works in the power management with help of these choppers and inverters. That is how the power is delivered to the electrical vehicle in the appropriate way. Okay, so before going to these particular topics, let me share that, so these kind of controllers or converters, okay, the choice. Okay, so first, my objective on this presentation is maybe the choice. What is the choice of converters? What's the choice of controllers for our applications? So, and next one is algorithms. Okay, and what kind of algorithms can be used for this particular thing? And a third one, what are the key performance indicators we want to concentrate on electrical vehicles? So if you want to write any new paper in this particular area, we are going to combine only these three aspects, okay, rather than telling the basics about chopper, buck converter, boost converter, Luo converter, Johnson converter, and interleaved boost converter, like that. So those things comes to be like a basic, or which has been already in the book. And also when talking about the inverter, like three-phase inverters, and also 120, 180 more multi-level inverters, different configuration, modular inverters, matrix converters, on everything. So that's all available in the text. So now we are going to focus on what kind of inverter choices or converter choices, and what kind of algorithms, and what kind of performance indicators. Before we are to answer all the three questions, we need to know about some kind of the things or the internal morphological features of our electrical vehicle. So the presentation motive of mine will be on, so we are going to give some introduction to the electrical vehicles, okay? Because many people would have been thinking that it is a new concept which has been started in the year of 2020 onwards, or 20,000, 2000 onwards. But this is a more than 150 plus old story. Okay, it's an old story of 150 plus years. Okay, it's a very old story. Even the people those who have been using this electrical vehicle 150 years ago, so they will be also using a similar kind of block diagram, similar kind of notations. And how we are going to make a control, how we are using the same old story to meet the demands of the present environment. That is our objective. How the old story we are going to meet the needs of the present. If the petrol or diesel are abundant, if the petrol and diesel are given at a very lower price, we won't bother about it. But still, how we are going to make it for the present thing, and what are the various control of electrical vehicles? So, being the electrical engineers, so this is the control of electrical vehicles. So we know that the motor which has been used predominantly on three-phase induction motors in most of the vehicles like Chevrolet or Tesla. Okay, so they are using the three-phase induction motor. Okay, so what kind of control can be made for this electrical vehicles, and what are the control strategies for the charging system in electrical vehicles? And we are going to give an insight about how to select the motors for electric vehicle applications. So while completing this, and next phase, we are going to discuss about the battery management system and how to model a battery, and what are the requirements of this battery management system, especially for electrical vehicle applications. And then we are going to calculate about state of charge and depth of discharge. This has already been available, state of charge and depth of discharge. How many, so for an example, how many charges been presently available, and how many charges you have been used. Okay, that's how many things are discharged and how many things are presently the state of charge. My area of research is on SOH. Okay, so SOH deals with the state of health. Okay, so here I'm dealing with the area, the state of health. So we are going to monitor the battery mechanism for the complete duration of cycles, and we are going to indicate the health parameter of the electrical vehicles. And then we are going to conclude the session by going this ongoing and upcoming research issues in EV technology with relevant to power electronic converters. So these are our recent books. So the first book which I want to introduce you is we have done a book on power electronic converters for electric vehicle. These are not edited books; these are authored books. All the three are authored books. Okay, so which has been done by me and also by Professor Dr. Ashok Kumar. So we have done by the power electronic converters for electric vehicles. So in this book, we dealt with all the different type of power electronic converters for the performance improvement in this particular thing. Okay, so here. Okay, we can able to understand that there's a first content, how the power electronic converters can be used, okay, for this performance improvement of electrical vehicles. So in this presentation, I'm going to utilize the content what I was already discussed in this particular presentation, in this particular book. And one more book we have also written on the power electronic converters for solar photovoltaic systems. Okay, so this book has been published by Apple Publishers, that is on Elsevier. Okay, this is on Elsevier. It was indexed in Scopus. Okay, so all the 11 chapters has been indexed in Scopus. Okay, so you can able to make sure that these kind of books has been given things. So, and the third book is on the computational paradigm techniques for enhancing the electrical power quality. So here we work across about both various controllers which will enhance the power quality in our thing. Okay, so in our case, okay, Guldeep, please. Guldeep. Okay, so how we can able to use this particular thing, Guldeep. Okay, so where we can able to understand these other things. So after introducing the books, what we have done, so as a basic introduction about that, that is when we are talking about the front runners of electrical vehicle, we have seen that China and US are the front runners in the EV industry, and we are quite emerging in the area of electrical vehicles, especially for the battery powered cars and vehicles. So, what is the range of electrical vehicle and the price comparison? So, here I have compared the different electrical vehicles starting from Tesla Model 3. So, it has been a charge of US dollars of $42,900 US dollars. And similarly, the Tesla Model SUV, it cost around 88,000 US dollars. So, like that, we have given the different price list of each and every cars. But one thing we can able to understand that all the top models like Tesla model and Nissan, Jaguar, Audi, and Hyundai, and Kia Niro, and BMW, Chevrolet Bolt, and Mercedes Benz, and Porsche cars, and Volvo. So all these things, the prices have been starting only in the range of around more than 40,000 US dollars. So in the present day, we can able to understand $1 is equal to 81 rupees. Okay, let us assume that if you're going for a 40,000, you multiply by 81, it comes around nearly around 32 lakhs or something like that. So we are getting that kind of amount when we are converting this US dollars into Indian national rupees. It will be converting to the model more than 30 lakhs or 40 lakhs. So a typical Indian mind, what it will think, when you're having this 30 lakhs or 40 lakhs, we normally invest in gold or we normally invest in land. We will never invest in the electrical vehicles. So my area of research attention is, so instead of making a new car, and what are the strategies which we can able to follow to reorganize or rechange the car that has been presently available, reconfigure. For this methodology only, we named our topic of our research as triple R. Okay, so triple R says that R. Okay, so this triple R can be done with the help of power electronics. It's not a movie, so it's like a triple R. Okay, so first R is for a repair. Okay, we are telling for the repair. Okay, so whatever the components is come to the fail mode, either a motor or a battery, if it is a failure mode, with the help of power electronics, you can able to repair. So that's what I will show you one of my publications in IEEE transactions. There we dealt with the fault tolerance systems of FTS with the help of a power electronic converters for purpose of repairing this one. Okay. And second R will be for reconfiguration. Okay. So that is called reconfigure. Okay, reconfigure. So what are the things which we can able to do the current present vehicle? So making the electrical motor to be replacing that machine that has been, that's IC engine will be replaced by this electrical motor. Just for replacing. Are we going to spend only for this replacing to this particular money, like 30,000, 30, sorry, 30 lakhs or 40 lakhs like that? A normal typical Maruti Suzuki Alto like type of vehicles comes around 6 lakhs to 7 lakhs. Okay. So now what we're going to do, we are replacing the engine with the electrical motor. Just for replacing engine with the help of electrical motor, and the battery is already available with the normal IC engine based conventional vehicles. So the only replacement is we are replacing the engine with the electrical motor. Are we going to spend money of 40 lakhs or 50 lakhs only for rechanging the engine to the motor? Okay, so that is the biggest question. So we need more number of engineers in this particular area to think in this perspective that rather than purchasing a new, so I'm not away from the topic, or I'm not away from the branded industries or companies who are manufacturing electrical vehicle. My concern is because our typical Indian mind will always says that, we have to spend certain things for land, certain things for future, certain things for medical like that. So for transportation, whether we want to spend around 40 lakhs or the 6 lakhs vehicle we are going to convert into this particular thing. So our triple R says that repair or reconfigure, or we can able to make that, it is called as a reconfiguration or reorganize. Okay, so that is what the thing we are doing. So either a repair or reconfigure or reorganize. Okay, the entire organization can be reorganized in this particular thing. So these are the three different vehicles that has been emerged in the history. The earlier it was called as a steam cars. Okay. So the steam cars, the normal requirement is water heating, and we want to waste a number of amount of water. So that has been converted into the IC based engine. So the drawbacks of IC based engines are, one is our noise and also the difficulty in starting. Now, not now. The early stages of IC engine, there was a difficulty in starting. Now, the drawbacks in the electrical vehicles are two major drawbacks. One is it can be useful only for short driving range until or unless you have a different charging station. For an example, if you want to travel from Hyderabad to Trivandrum, so for that particular range, at least you should know whether the charging stations are being available. And the second important thing is poor battery performance. Okay, so what are the various mechanisms? So we are going to address these two drawbacks. So while addressing this, before that, we want to understand some basic definitions for the electrical vehicle. So the electrical vehicle means it uses either one electric motor or more electric motor for propulsion. So we are replacing that internal combustion engine with aid of this electrical motors. And battery powered electrical vehicle means it is powered by battery. Hybrid vehicle means which is having both batteries and also IC engines. Okay, so hybrid electrical vehicle, that's a battery, it will be powered by this and from the IC engine. So here also we can able to make use of this electrical motors or IC engines like that. And plug-in vehicle means where we are going to plug in with the grid. Okay, so here we are also going to see some kind of attention towards the grid interaction with help of power electronic converters. So we also work with the thing of proper grid connectivity. So we are having a grid simulator and we will be working with the grid interaction. That is, we are going to maintain the voltage and also the frequency and the phase and appropriate as per the abiding the grid codes of India. So these are some of the examples of the electrical vehicle. Okay. So some of the examples are Chevrolet Volt. Okay. So and next one will be the Mitsubishi electrical vehicle. So these electrical vehicle, the only thing we have to understand that it is a branded Mitsubishi or Chevrolet. The only thing is they replaced the engine and they kept the electrical motor. Okay. That's the AC motors. So what are the benefits of driving electric? So I'm not going to read the slides, just the salient points. Okay. So it will save the fuel cost and the emission will be get reduced and it will reduce the dependence on foreign oil and we can able to get the much more satisfaction. Okay. So it is a win-win situation for the utilities and also for the customers. So the need for EV will be to limit the carbon dioxide emission because whenever you are consuming the 1 unit of electricity which has been produced by the conventional fossil fuels, we are emitting 1,000 grams of carbon dioxide. This is the thing, carbon dioxide. If you are consuming 1 unit of electricity, it symbolically means that you are emitting 1,000 grams of carbon dioxide. Okay, in one particular house. I'm just telling for 1 unit. So the carbon dioxide emissions can be get reduced and also we can able to make integration of renewable energy for this electrical vehicles. So when comparing with the conventional vehicles, so when we take an electrical motor, okay, so electrical motor, we are going to compare with the engine. Okay, so when we comparing the efficiency of the electrical motor and the engine, the efficiency of the electrical motor is about 70 to 85%. Even in our machines lab, we are doing some experiments and we are getting some efficiency about 90% for the brand new machines. Okay, so here we are going to get the efficiency will be 70 to 85%, whereas the efficiency of the heat engine or else the engines what we are using, it will be some numbers only, not nearer to this particular value. That is one of the major advantages of electrical vehicles. And also electrical vehicles can able to make use of this regenerative braking such a way that the 30% of energy used theoretically, it's a theoretically, but we can make you a reuse of that. And also the electrical vehicles are environmentally friendly and when the oils are depleted, we can make use of these electrical vehicles. So these are the different varieties of kinds of electrical vehicles that has been useful for various purpose. But this usage in our country is quite limited. But now we are emerging to use all these things in our near future also. And these are the different kinds of electric cars like hydrogen fuel car, solar racer, hybrid, full size car, and MIT city car. MIT stands for Massachusetts Institute of Technology. I will say the story of Massachusetts Institute of Technology later and neighborhood cars. Okay. And then, so while telling the history of electrical vehicle, so you don't think that I will take a much more time for telling the history. So the history is required that, because I want to mention that this electrical vehicle is more than 150 years old story. Okay. So in the year of 1832 to 1839, a British inventor, Robert Anderson, he invented a crude electrical carriage. Okay. So this was the starting early history of electrical vehicle. So we can able to understand now we are going to reach around 2022 or 2023. So soon we will be reaching around the year of 2032. Let you assume that, it is nearly around 200 years. Okay, 1832, 1932, 200, 2032. So more than 200 years of story of electrical vehicle. Okay, and after that, Thomas Davenport. Okay, Thomas Davenport is an American. He has made a first practical electrical vehicle in 1835. Okay, so he has made a first electrical vehicle, a small locomotive in 1835, and later this was a patent. Now, this kind of patent, or so many patents are available. This patent was granted in England in 1840, such a way that they are used for the rails. Okay, such a way that they made use of a DC power supply. So the positive point and it will be the return point will be the same vehicle. Okay, so the running rail will not electrically connected. So this is the negative return path. This is a positive rail, positive and negative. So the DC power supply will be pulling this particular electrical vehicle. So it has been for a short range. This was get patented in 1840. And later, the French physicist, the Gaston Plant, in 1859, he invented this rechargeable lead acid storage battery in 1859. So this has made a remarkable thing on the usage of lead acid battery. Now we are using a lithium ion battery. Earlier, the history was started from the lead acid battery. So the lead acid means, because we know battery consisting of two terminals. One is called anode, one is called cathode. Okay, so normally the metal related particles will be take the anode, and the gaseous substances will be taking gaseous or liquid substance will take the role of cathode. Okay, so the metal means the lead is a metal, so it will be taking the anode and the acid will be taking the cathode. So the action between the anode and cathode will makes the positive to negative ions to move the electric field circuit. And then in the Camille Alphonse Fureur, a French scientist, he approved the design of battery in 1881. And Thomas Parker, he has made underground tram railways in London in 1884. So the earlier electrical vehicles will be like this, which will be carrying the like a carriage where we can able to connect a battery and a small motor, which makes the wheel to rotate. So this was the very old story. And the first electric car in Germany was made by Andreas Flocken in 1888. And the United States, the first electrical vehicle is about 1890 to 91 by William Morrison in the state of Des Moines. Okay. And we can able to see from the year of 1890s to 1900, this is called as a golden age period of electrical vehicle, because there has been so much of increase in motor vehicles, electric vehicles. So that age is very thick. So the people, they will be using the exchangeable battery service. So many people, they are working with a area of research called battery swapping. Okay, so that technology was more than 100 years of technology that has been used earlier. So this battery, whenever it is completely drained or completely used, they will take the battery and they will give to this electrical, some companies like that. So they will take the charged battery and then, so even the Ola electric cars, Ola autos in Chennai, they're using the same process, which the process that has been proposed in the early of 1896. Okay, so once when they're going in the auto, suddenly the battery is completely getting drained. They will take the battery and they will fit into the charge swapping thing, and they will take the charged battery. They will fit in this. So in this area also, there are so many topics or so many researchers are doing the research in this particular area on the battery swapping. One the battery. So this was doing by manually. Even the Chennai, even presently, you can able to see they're doing manually. They will pull out the battery, they will keep it in a charge box, and whichever the battery which has already been charged, they will take that and they will put it in the vehicle. That's all. So this is done by manually. Even we can able to think of some kind of technologies where we can able to make use of this automatic removal and automatic fixing and automatic pulling. For that, obviously, we require some hands. We can think of some robotic based battery swapping or some kind of technology where the battery can be pulled, can be fixed automatically. So the acceptance of electrical vehicle was very high in the years of up to 1912, because most of the houses were emerged with electricity, and there has been a enabling a surge in the area of cars. So many people's, so sales of electric cars was peaked in the 1910s, very peak. So this was one of the advertisement given by New York Watertown by Babcock Corporation. So they have been selling a 35 HP of electric vehicle. So they are saying that we can shall be able to make a deliverables in April. So at that time itself, we can able to see $2,750 for a 35 HP electrical vehicle. So we cannot able to convert this into Indian rupees, because this was made in 1910. Because after Indian independence of 1947 only, we made a conversion of dollar to Indian rupees. Okay. Earlier, there is no conversion. So we cannot be able to imagine that what is the price equivalent to Indian rupees because it was pre-independence. So we cannot be able to compare the price. And then there was a decline in electrical vehicles. Now the gasoline cars and the fuel cars, they become very easy because the electric starter, because earlier it was a starting problem with the normal IC based engine cars. The electric starter was invented by Charles Ketter King in 1912. So what we talk about on 2-point starter, 3-point starter like that. So the earlier starters was developed by 1912. And after that, the decline of electrical vehicle was made because of the mass production of Henry Ford. He has made a Ford electric company, and then the electric car made a stop to the production at the same point in 1910. So in the 1889, it was started the thing and it was stopped the production in 1910s. Now we are talking about electric vehicle from 2010. That's all. But the components involved in the electric vehicle remains the same. Okay, but they may not be using the stylistars, then they may not be using some advanced controllers or closed loop controllers, but now we are using that. That is the only difference. Other than that, the general block diagram remains the same. So this is a timeline story of a summary of this, whatever we have talked about on electric vehicle, started by 1830s and ended by 1910s. That's all. So this is the story has been ended for electric vehicle. Now, after this 1910, there was a great electrical race which has been conducted in the 1968. Okay, so they made an electric vehicle. So from Boston in United States, okay, where we are having this Massachusetts Institute of Technology in Boston, from here to California, they made a cross-country race. As we are making some race between Kanyakumari to Jammu Kashmir, they made a cross-country race between Boston to California, only with electrical vehicles. So they are continental race between this MIT and the California Institute of Technology, Caltech. So in between these, they have kept a 53 charging station. Okay, so they want to travel across this country. In between this region, they placed a 53 charging station. Each and every charging station they kept 60 miles apart. So so if they're keeping one charging station here, they will keep the another charging station 60 miles apart. So based upon that, they kept a 53 charging station. So at that time, the MIT cars, they used the $20 of nickel cadmium batteries, and the Caltech cost is about in that way. In the 1968, this is a very, very higher cost. So this has given insight to the whole world that the electric cars, without the usage of gasoline or fuel, can able to run across the country. So this has made a big revolution in the area of electrical vehicles. So this is my photo. So when I visited this MIT, so where the cross-country race was started, this is a Massachusetts Institute of Technology, where the race has been started in 1968. This I have taken this photo when I was visiting there in 2017 in MIT, pre-COVID. And then we can able to see in the 1968 or later the 1968, many people are started towards that there is no gas because of the production has been. So this has created the interest, this renewed, it's not created, it renewed the interest in electrical cars because many people came to like that there has been an energy crisis in 1970s and 1980s. So then they renewed some interest in electric cars. So after the renewal of interest in electric cars in 1990s, the California Air Resources Board, they made a clean air agency that has made a thing of Air Resources Board. So that is the reason the Tesla was developed in California. Okay, so it's in the region, okay, of United States. Okay, so that is we call it about the western region of United States. So then the people started with the hybrid electric vehicles where the vehicle will run with both oil, fuel, along with a battery. So it's a way hybrid. So it was making a balance between these two vehicles. Okay. So even the oil is coming down, the battery can able to restore the losses and they can able to fulfill the requirement. So now we can talk about on the modern roadster electric vehicle. So this has been developed by the Tesla Motors. They started this thing in 2004, and after the 4 years of R&D, they have delivered to the customers in 2008. This is a Tesla Roadster. So this is the first highway legally approved, okay, legally approved all electric car which made use of lithium-ion battery. Okay, and this is also the first production all electrical car which travel 200 miles. In India, we can say that 320 kilometer per charge. So once the vehicle is charged completely, it can able to travel at a distance of 320 kilometers. You can ask a question, sir, whether in India for per charge, whether we can able to travel the same distance. We cannot say, because it all, while charging, while moving, it also depends upon the conditions of the road in which you travel, whether you're traveling in the same plains or you are going to climb the hills. So based upon that only, the charge will take. Because once you climb the hill, you require more power there than of the energy. You require more number of power. So that power cannot be given by the battery. Okay. And also while making so many loads inside the car, for taking such a high amount of load, more than the energy, we need a power. Okay. Power is requirement. But we know that, this kind of battery, this is completely on energy based. That is the reason energy, we know that it is called as a power into time. So we normally call the battery as a AH. AH means we can say that, it's a time oriented. So it's a energy. So battery is having peak energy, but it is having reduced power. Power is less, but the energy is high. But for climbing the hills or you take heavy loads, you rather than energy, you need the power. Power is equally important. That is the reason nowadays, in along with battery, the people are talking about super capacitors or ultra capacitors. So super capacitors or ultra capacitors are used. Okay, it is not a substitute for battery, or it is not a stepney for battery. Battery is can able to find some difficulty while climbing the hill. Okay, so battery is finding some difficulty. So to alleviate the difficulty, we can replace the battery with help of a super capacitor, ultra capacitor. That is the only role, because super capacitor is having high power, whereas the battery is having high energy. Okay, for moving the hills or taking the heavy loads, power is required than that of energy. Okay, because energy is time oriented, where the power is equal to energy divided by time. And then Mitsubishi, they launched in the Japan in 2009 for individual customers and delivered in 2010. And Chevrolet Volt, so they traveled about with only with the help of a plug-in hybrid car, and which can able to run a generator which charges the batteries. It's a Chevrolet make. And then this is called as the dynamics of electrical vehicle. Okay, so this dynamics, normally the people from automobile engineering, this is the one of the basic thing what the people should know about the dynamics of electric vehicle. Here you can able to see why we are going to see the dynamics of electric vehicle. So the dynamics is very, very important. In what way it is important means, so it gives a future that how much of power is required to run an electrical vehicle. That speaks about this dynamics, because normally we can able to understand this dynamics will give you how much of power required for moving and what is the rating of the battery requirement. So those things can be given by this dynamics of battery. That is, it will give you a complete picture about what is the value of voltage and what is the value of power requirement. So everything it is made with the help of the size of the car. So here the M stands for mass of the car and G stands for the gravity, and we are having based upon the angular movement of the car, we are making it as a sine theta and as well as the cos theta. And here we talk about the different resistive forces that acts in the battery limit. So much of thing it will act. Okay, so where we can able to understand that some forces like aerodynamic force. So that aerodynamic force equation is given over here. Okay, so it is F aerodynamic force is equal to half into rho A CD V minus VW the whole square. Okay, so the aerodynamic forces are equal. So we can able to say that it is uh, kinetic energy. This is a kinetic energy. Kinetic energy means we can able to see it's a half mv square. So the mass I'm giving it as a this particular term is taken as a mass, and the velocity is given by velocity the whole square. So here the v is called as the velocity. So the aerodynamic force on the vehicle are proportional to the velocity square, and it is becoming the dominant at high speed. Okay, and here we can able to see that this force, okay, where we can able to understand the rho is called as a density, and we can able to assume that it will be equal to 1.225 kilogram per meter cube. Okay, so where we can able to see there are so many different kind of forces will be takes place. One such force is called as a rolling resistance. Okay, so rolling resistance means it is a simplest term. The rolling resistance, a fixed term, dependent on the vehicle mass, gravity, and the tire coefficient. Tire coefficient, we will be given all the things. So CRR will be equal to the tire coefficient or deformation of the tire. So M is called as a mass and G is called as a gravity, like that. So here we can, so we normally know acceleration is equal to M into A. There is a mass into acceleration. Mass into the acceleration. So there are two forces will be acting when the movement of the car. So one is towards this thing and second one towards this aerodynamic force. Aerodynamic force means as like what we are studying from the wind energy conversion. Aerodynamic force. The force is acting towards this way. The air is acting towards the windmill. Okay. So from this air, what kind of reaction has been taken? That will be the normal conversion of energy. And we can able to say that, mg sine theta will talk about on gradients. Okay, so while we are driving the vehicle upon a slope or additional force will be depend upon the mass, gravity, and the angle of slope. So these are the terms. So we are going to collect all the forces and we are going to sum up all the forces. How we are going to sum up? So this is called as the force balance equation. Force balance equation is the force acceleration will be equal to the Ft. Okay, so what is the transverse force and the summation of the resistive forces? Total resistive forces. Actually, there are three resistive forces will take place. One is mg CRR cos theta, and another one is the dynamic resistance, and another one is called as your gradient resistance. So we are going to sum up all these three different resistances that has been pictorially given over here. Mg sin theta, mg cos theta, and these things. So these forces will act in the any kind of car. So from this, we are going to calculate the Ft. So we know that Ft is equal to m alpha plus summation of your resistive forces. So Ft is equal to m alpha and the remaining all the three forces. Now we coming back to our electrical concept. We need the power, okay, to drive a car, to drive a vehicle. Let us take the speed is about V. We call it as a velocity or we call it as a speed. we call it as the meters per second. Velocity normally called in the meters per second. Rather than in RPM, we call it as in the meters per second. Okay. So here the power is equal to, so what is the propulsion force multiplied by your voltage V? So multiplied by your speed. So force into the speed. These two get multiplied in order to get the appropriate power. So we can able to understand M alpha you multiplied by the speed, and each and every term we are going to multiply by speed. This term multiply by speed. This term multiply by speed. So this equation will give you, while we are substituting the speed requirement and the mass value and the gravity value and the tire deformation ratio value and what is the initial speed and the final speed and what is the mileage, while we are substituting this, we can able to arrive the answer that what is the power requirement to drive the vehicle. Okay, for the given speed, we can able to calculate the power. So one sample calculation I given over here. The same calculation I also included in my book as well. Let us take that you are taking a vehicle of 1,000 kg of mass and speed of 100 km/h. Here the formula is it's a force into the velocity. This is the formula which I given you earlier. So now I'm going to substitute alpha is equal to 0. That is the angular moment. And the rho, it has been air density is given by 1.225 kg per meter cube. And then the A is equal to area of the front up area. That is the area is 2 meters square. And CRR is equal to the ratio of 0.02. And V omega is equal to 0. And let us take the theta is equal to 0. And the ratio of CD will be equal to deformation ratio is equal to 0.5. While substituting in this particular equation all these values, so these values we can able to arrive from any vehicle dynamics, as we call the data sheet for any kind of IC or any kind of electronic components, we get a data sheet. Similar to that, we'll get these kind of values for any kind of vehicle. Substituting this vehicle, this component, we can able to get the power values equal to 31 kilowatt. See, we can able to understand mass substituted as 1,000, alpha is 0, mass is 1,000, gravity, CRR is equal to 0.02, cos theta is taken as 0. Okay, so cos 0 is equal to 1 and half is taken as 0.5 and rho is 0.2 and A is 2 and CD is given as thing and VW here we are going to take it as a velocity. So here it is given as a 1,000 km/h. Converting 1,000 km/h into meters per second, we can convert it as a 28. Okay, that is multiplied by 5 by 18. So we can able to get us 28. So while converting this kilometer per hour to meters per second. So here we talk the speed in kilometer per hour, normal thing. So here the formula it takes the value in the form of angular speed. That's called, it's like a velocity, like meters per second, what we measured for the wind. So we'll get the speed, the total power is 31 kilowatt. So this is the normal power requirement for any vehicle. For an example, if you want to accelerate the vehicle from 0 to 100 km in the initial 10 seconds means, again, we have to use one more formula. Power is equal to mass into the half the rate of your speed, that is a 14, into the same thing, that is a 2.8. It's multiplied by your, divided by your 10. So 2.8 is, it's not 2.7, it's a 2.8 into half of the 14. So this particular thing, we can able to get the value as 38 kilowatt. Now we are adding this. If you want this requirement, we can do. If not, we can end up with a 31 kilowatt itself. So this is our requirement or any kind of your constraint. Okay. If there is no constraint means we can able to end up with a 31 kilowatt itself. If there's a constraint is there, we have to make it as a mass and 28 divided by your 100 and half of the 28 we'll get a 38 kilowatt. So 31 plus 38 will get us a 69 kilowatt. So the maximum power requirement for a vehicle of mass of 1000 kg and the speed of 100 kilometer with help of this aerodynamic equation, like a dynamic equation, we can arrive the maximum power of 16 kilowatt. Okay. Yeah. Okay, so that is the thing. So you can take any vehicle. So one of the papers what we have done recently, we done for a vehicle called what else to say, a school bus. Okay, and a school bus. For that particular school bus, yes, mhm,
Yeah,
yes. Hello, I think somebody is
sir, Raghu
muted.
sir,
Raghu sir, yes sir, tell me sir. Raghu sir, okay, fine. So now we are going to see about the range calculation. For an example, a battery capacity, energy capacity of the battery. Energy means we know that power into time. So power is given by 40 kilowatt. Power is equal to voltage into current. Okay, VA, that will be given by watt, and the time is given by hour. So VAH. So here we are taking, when we are taking a battery of 40 kWh. Okay, so out of this particular battery, we are using 20 kilowatt to run for an example of 50 kilometer per hour. For example, using the vehicle, it runs a 50 kilometer hour, utilizing the 20 kilowatt of energy from a battery. So the battery can able to release a 20 kilowatt of power for 2 hours. Okay, so we can able to understand that since it is having 40 kilowatt, so it is releasing 20 kilowatt of energy to run the vehicle at 50 kilometer per hour. So we are having, with the help of 40 kilowatt hour, we can able to make use of run by 100 kilometers, 100 kilometers. So because 50 kilometer, you are utilizing 20 kWh. The remaining 50, you are using the remaining 20 kWh. So out of 100 kilometers, you can able to make use of 40 kWh. So we have to keep that range calculation means you are putting one charging station over here, you're charging a car. At the end of this 100th kilometer for this vehicle, we can, it is requirement for charging station because the battery. So we have to decide the location of the charging station based upon the capacity of the battery. Based upon the capacity of the battery, we can able to fix the charging station. Either from here means here. So for an example, I'm starting from the location point as X means, and my next point will be Y. For an example, somebody will be charging over here. Let us say that they're taking the Z point means there is a, let us take the B point will be something different. So the appropriate range of calculation can be determined only by the capacity, energy capacity of the battery. So now let us see how economical with a conventional vehicle with the electrical vehicle. So conventional vehicle average mileage will be per liter. It is about 15 rupees. Now the 1 liter of petrol is about 102 rupees or 105 rupees. So while you are calculating the mileage calculation for per kilometer, you are spending the rupees of 6.77 rupees. For the conventional vehicle, even you take a car or whatever it may be, for traveling 1 kilometer, you are spending nearly 7 rupees. If you are taking with a battery whose capacity is 40 kWh, it is having the range of 120. And here we can able to understand for charging the electrical vehicle, so 1 unit is equal to 8 rupees, because charging the electrical vehicle will not come in the residential cost. The residential cost will be 1 unit will be 1.75 rupees to 2.25 rupees. But for electrical vehicle, it will not come under the residential, it will come under the commercial price. Commercial price is about 1 unit is equal to 8 rupees to 12 rupees. Let us take for 8 rupees. So we can able to understand for 120 kilometer, you are paying for 320 rupees. So as per the electrical vehicle, for per kilometer, you are spending only 2.6 rupees. Now we can able to compare how much of price we are using for the conventional vehicle and how much of price we are using for the electrical vehicle. So these are some of the upcoming and the present electrical vehicles, the different models and the different varieties, and how much of miles it will go for per charge. So these are some of the popular electrical vehicles I have taken into comparison, comparative analysis. So here I will show you our electrical component for all these electrical vehicles. Then we can able to adopt our power electronic converters for the performance improvement of the vehicles of electrical vehicle, because already things have been done like a Nissan Leaf, Ford Focus, BMW i3, Chevrolet, Tesla Hills, Mitsubishi, Renault Tuzo, and Nissan ENV 200 model. Let us take first model, Nissan Leaf. Okay, so this will be comprising of some kind of mechanical components like bumper and petrol tank and the door and all, everything will be something like a mechanical component. As the electrical person, we have to concentrate only on the power train. Why it is called as a power train means we know the train is having so many compartments, one, two, three, four, like that, some compartments. So here we talk about on compartments. Okay, so we'll be having a battery. So we have to charge the battery. From the battery, it will be given to a motor, and from the motor, it will be given to the transmission line. From the transmission line, it will go to the wheel, and finally we are taking to the wheel. So this complete thing is called as a power train. Let me talk about the Nissan Leaf. They're using the battery. They're using the lithium-ion battery and the lithium-ion battery only. It's about the rating of 24 kWh. So here I've given the model of Nissan Leaf. Okay, and also the transmission. Transmission means the thing which connects the motor with a wheel. Okay, so let us take a motor like that, and the wheels are like the thing which connects the motor to the wheel is called as a transmission. Okay, so how the power from the motor is transferred to the wheel for its possible rotation, that we normally call as a constant speed ratio thing. And electrical motor, Nissan Leaf, they're using a synchronous motor. So the rating of the motor is about 80 kilowatt. 80 kilowatt means it is about the range of 110 HP. So whenever you're going to do any project or any design, you take any one car as a reference. Even if you're doing some MATLAB simulations, you take any one car as a reference. Even you take a Nissan Leaf as a reference. Even in your Viva voice or any questions, there are any reviewer comments, they will be asking you why you have taken your motor as 80 kilowatt. You have to say that, for this 80 kilowatt, it has been used in Nissan Leaf, so I used the 80 kilowatt. And why you choice of the synchronous motor. Okay. So what is the role of synchronous motor? Why can't it maybe an induction motor? Why they're using a synchronous motor? And when we compare this induction motor, synchronous motor, we know that this motor can run only with a synchronous speed of ns is equal to 120 f by p. So here we can able to understand this is a motor rating. Based upon the motor rating only, we have to design the rating of the battery. Okay, it's a charging. Okay, so now this particular battery, it is able to provide the power for 80 kilowatt. Okay, so we can able to understand, you can ask the question. So this is about 80 kilowatt, but they're giving a battery of 24 kilowatt or 30 kilowatt range. Okay, it's about kWh. It's only kW. Okay, so how much because we are giving the power in the continuous. And there are based upon the different designs of this particular car, we can able to see that for 117 kilometers, we can able to give one charge. So estimated point average. So these are the some standards being given by the different electrical vehicle manufacturers like EPA and NEDC. These are standards. Okay, as a standard, it can able to run up to 173 kilometer per charge. Okay, so whenever you are going to purchase an electrical vehicle, so we have to concentrate on electrical motor, its rating, and it's the name of the motor, what's the torque, and what's the transmission, what's the type of battery, what's the rating of battery, and what's the range of that. So based upon the different models, okay, MOI models, we can able to get. And again, plug-in charging. So we want to charge the battery, so we want to get a charge. So here the charging can be, it may be 3.6 kilowatt for this particular car, and 6.56 kilowatt, it can be charged by 240-volt AC. So it's a socket, okay, or else a 44 max of 44 kilowatt 480-volt DC on a cadmio inlet or adapters for domestic AC sockets. So certain sockets or certain adapters only applicable for certain cars. So we have to check that, what is the input range we have to give. So whether what all the things are available. So this has to be get standardized. Okay. So because many vehicles are having many different ranges of sockets and adapters, many choices. Next, we move on to the Ford Focus Electric, the second car. Okay, so in this particular car, we can able to understand here also they're using the synchronous motor. They're removing the engine. Based upon that, they're replacing with a synchronous motor. Transmission is one speed, and battery is 33.5 kilowatt lithium-ion battery, and ranges per charge is 185 kilometer, and plug-in charge will be onboard charger. Okay, and also inlet and DC fast charging with the continuous connection CCS. Okay, so here we talk about on fast charging and slow charging. So normally the DC charging will be quite faster. Okay, so that I will compare later about a different variety of charging. Okay, while we are making some comparison of battery, I'll explain that one. And here we talk about on BMW i3. Okay, so this is the BMW i3. So what is the unique property of this battery? This car means they are having both electrical motor and also the engine. Both the things are available. Whereas when we talk about on the earlier cars, we are taking only replacing the engine with a motor. But this vehicle is comprising of both engine and as well as a motor. Okay, so here they have not specified what's the type of the motor. They've used, obviously, they're using the AC motor, but they have not mentioned the type. And the engine, it has been a cylinder generator optional fuel capacity. And so it has been the standards of Europe and US. And battery, again, lithium ion battery only. So most of the vehicles, whatever I shown till now, they're using only the lithium-ion battery. That is the reason why many people they are doing the projects on lithium-ion battery. In addition to that, there are other batteries like nickel, magnesium, hydride battery also can be used. Okay. And also that depends upon what is the anode material and what is the cathode material. So anode material will always a metal, and cathode material may be a liquid or gaseous state. So electrical range will be the range has been given for the different models, and plug-in charging will be onboard charger or combo optional combo DC. Okay. And next is a Chevrolet Volt. So Chevrolet Volt also is having the engine and as well as the electrical motor. The motor they've used is called as a permanent magnet motor bar generator, because towards this action it has to work as a motor, towards a reverse it has to act as a generator. So that bidirectional mode and the electric motor, the engine, and the transmission will be multi-mode electrical transaxle rotation, and the battery will be about the lithium ion battery, and the range will be of the certain miles, and the electrical range and the plug-in charging will be 120 volt 15 amps AC or 240 volt 20 amps AC. And Tesla, yes, the Tesla, they're using the electrical motor. So here comes, because most of my work, I'll be using either a brushless DC motor, or I will be using for electrical analysis a three-phase AC motor. If somebody is asking you why you are using this motor, means I can say that Chevrolet I've taken as a reference, and the Chevrolet they'll be using as a permanent magnet motor, PMBL DC motor, permanent brushless DC. And here we are using a three-phase induction motor. And the battery is again a lithium ion, and the range has been given for the different modules, and the plug-in charging may be onboard charger or off-board charger. Okay, so the options has been given as optional charger, dual charger, and supercharger. So those options are available. So that is the reason why these cars prices are quite high, because of these various options. And Mitsubishi car, you can able to see the electric motor, they are using the permanent magnet motor. So whenever we are writing a paper, we can even refer these cars in our references that these motors are being used in this particular car. Okay. And the battery is again lithium ion, and the range has been given. The plug-in charger will be both the DC socket and also for your AC socket. We can able to use optional sockets. While we talk about the basic structure of a hybrid vehicle, this is a normal basic structure. That is, we talk about on integrated power electronics. That is our topic of today class on power electronics for improving the performance. So here we are having the electrical machine and the battery pack, and we from the battery pack we are having the manual transmission and the clutch and the final drive has been there. So this is the internal morphology. The role of integrated power electronics is to improve the performance, and we have to draw the energy, maximum energy, and to manage the power and energy requirements. So these are the three different part of vehicles. We are concentrating on the conventional, where the fuel and engine and the transmission line. This is a transmission. And the hybrid vehicles, we are having the battery to the in transmission or the fuel to the transmission. And the battery electric vehicle, the battery to transmission. While it's coming over here, it's acting as a motor. During the reverse, it will be acting as a generator. So here the structure of the design will be classified into three types. So one is called series thing when we talk about a hybrid. So have we know that hybrid consisting of both engine and as well as motor. Okay. So here we talk about a power electronic thing. So here we have a battery, first one. From battery it is given to the inverter, and from inverter is given to the motor. So so whenever you are attending a review or a paper submission, they will ask whether your design is a series or parallel or hybrid design. So in the series design, we can in the series. Uh, Sir, please, sir, please mute, sir. Okay, so in the series design, we can able to see the power flows to the wheels in series. Okay, so from the battery, the power flow from here and reaches the wheels. And similarly, from the engine, it is not going to the drive wheels. From the engine, it is going to the generator, and from there, it is going to the motor like this. Okay, so this is called as a drive power. This is called as a electric power. Two different powers will takes place. To drive the wheels, we are using the because we are using a hybrid, either engine or as well as a motor, or as well as a motor. So here the role of power electronics is to convert the DC to AC, because most of the motor we are using is a AC motor. So we need to have an inverter. Inverter is essential for this one. So where we can able to see whatever the thing, whether you're using an engine or a motor, the power flow will be series. Okay, so these series kind of motors can run a output engine, okay, and it'll be a efficient operating to the electric motor. And this system is used in the coaster hybrid based cars. Now we come back to the parallel configuration. The parallel configuration, the power flow to the wheels will be parallel. So from the motor coming like this, and from engine coming like this. So both the powers will reach the transmission line. So we can make utilize the two sources according to the condition. Okay. So when the battery is low, you can make use of the engine. Okay. When engine is not available, you can, when this is abundant, we can able to use. Okay. So this is most predominantly we use this because the power flows to the wheels in parallel. And next is called as a hybrid. So hybrid will be the combination of both series and parallel. So the series hybrid means what is the usage of both engine and motor, and parallel hybrid means how we are using the engine to the motor, or the hybrid series parallel hybrid means we can able to see how the motor and the engine are appropriately used. What's the role of motor and thing. So here when we speak about to the series parallel, it can go either a series or either it can go as a parallel, or it can able to make a power split to this particular direction, the way how the power is delivered. So now let us see about the various kinds of electric vehicle and the plug-in electric vehicle. So let us say that, for the role of this particular thing of hybrid electric vehicle, we know that we consisting of both an engine and as well as a motor, two things. So then we will call it as hybrid electric vehicle. Now let us say that, this is a normal vehicle, what we run at present. When you put the gasoline means the petrol. When you put the petrol, leads to the combustion engine and it makes the wheel to rotate. So based upon the rotation, what is happening? It makes the rotation, so the mechanical energy of rotation will be converted into electrical energy with help of a generator, and it has been given to the motor. It is given to the battery. Let us take the batteries of 1 kWh. It is given to the battery. This is what normally will happening in our normal vehicles. And now, once the thing is happening at final stage, what the energy from the gasoline and again with the battery, both the things are emerged together in order to make the wheels to rotate. So that has been increasing our efficiency. It has been going. So this is what normally will occur in our basic IC-based engine, what we are using, because in our thing, we are having the engine alone, but we are not having a motor or a generator. But where we can able to see plug-in hybrid electric vehicle, so instead of this battery, we can able to place additional batteries. So let us say that 5 to 15 kWh, and we can able to charge with the externally, charging the battery with externally. So now this battery is giving the energy. Now this electric motor generator set will act as a motor, which will convert your electrical energy to the mechanical energy. So now that mechanical energy will be help us to protect the wheels. And finally, the gasoline, when the battery is drained, now the battery is drained because the power has been used, being utilized from the battery. Now, with the help of this gasoline, we can help of the combustion engine, we can able to rotate with. So, this plug-in hybrid electric vehicle, it's overcome the problem of battery electric vehicles. And then this is the range has been given for the plug-in hybrid electric vehicles. And it will be suited for our daily driving patterns. For an example, for day-to-day life, this has been doing well for the plug-in hybrid electric vehicle. That is the reason many people are moving towards a plug-in hybrid electric vehicles. Now, whenever you want to buy a car, what are your expectations? So, for an example, whenever you want to automatically start and stop the engine in traffic, suddenly, for an example, you're waiting in the traffic, suddenly the charge has been made drain. You want to start the engine, but it's not starting. But we want a vehicle to be automatically start and stop the engine in start and go traffic, because of traffic, you're not going traveling continuously. And also, you want to go for the regenerative braking. The braking should operate more than 60 volt, or else you want to make use of electric motor in addition to the combustion engine, and you want to drive the motor only using electrical motor, or else you want to recharge the batteries from the outlet. Okay, when your choices are these five choices, then what will be the vehicle? If your choice is first one, it is called micro hybrid. Okay, that is called the Citroen C3 vehicle. Okay, Citroen C3 vehicle. So this vehicle will automatically start and stop. Okay, start and stop in the go traffic. For an example, mild hybrid means it satisfies the three conditions. It can go in the start and stop in the traffic, and it can go abide with the regenerative braking, and also it can be useful for the combustion engine. And full hybrid means Toyota Prius. So this is the way how we have to make a choice of electrical vehicle. That is, the start automatically start and stop, and it uses the regenerative braking. It uses the motor for and it uses only with the help of electrical motor. When you want all the choices to be fulfilled, we can able to go for Chevrolet Volt. So the efficiency of the vehicle will be increasing from micro hybrid, mild hybrid, full hybrid, and plug-in hybrid. Okay, all the choices will be fulfilled with a Chevrolet Volt. That is the reason whenever we are making a choice of a vehicle, we have to see what is our need, what is our thing. So it is not on the brand, we have to fulfill. So our needs are given here, and then which are the needs are fulfilled by the vehicle. Whereas a Citroen, the regenerative braking is limited, and it cannot be able to assist the electrical motor, and it can able to run like this. So that is what the thing is happening in the particular vehicles. Now, this is what the types of electric vehicle that is called the plug-in hybrid electric vehicle. Okay, so let us say with the plug-in hybrid electric vehicle, we can able to see that it was make it as a charging your battery, and also the gasoline will be available. So this battery is given to the motor. Battery supports the motor, which is marked in green color, and the gasoline supports the engine. Okay, which are having both the battery and as well as engine. An extended range electric vehicle, we can able to see it's also the same, and we can able to see it is connected to the motor and then the engine, and again with the help of this gasoline. So both the things are same, but the configuration seems to be quite different. Whereas we talk about a battery electric vehicle, you just remove this gasoline, remove this engine. We use only the battery, only the motor. All the thing, only the greenish we are going to use. Okay. So when you go for the both the things, you can choose for the Prius plug-in, or when you want to this kind of configuration, Chevrolet Volt, or we can be able to go for the battery electrical vehicle. It is called the Nissan Leaf or Tesla S model. Now we are going to talk about our loss calculations. It's very, very important whenever we talk about on any kind of papers, writing the papers, So we talk about on the loss calculation. So here I have taken a simple case study to denote the loss calculation in the city driving. Normally in the city driving, when you take a city driving, Okay, we used to travel in the city. There will be so many speed breakers will be there, and so many kind of signals will be there. For an example, you assume that you are putting your fuel tank of 100% of fuel. So this fuel tank will be giving the power to the engine. Okay, so this is called as a powertrain for the normal IC based engine. So here we have taken for a case study of Toyota Camry, okay, 2005 model, a Toyota Camry. So from the engine, what is happening? The engine will be having the loss. Okay, because the efficiency is very less in the engine. That's what we already talked about. Motor is having efficiency of 85%, but the engine loss is alone it's 76%. That means it is only a 25% efficient. So the loss is 76%. And when the vehicle is standby, when the city driving, you have to go for the first gear and second gear standby. So that has been lost by 8%. So we can able to understand. So out of 100%, you minus this 8 and 76, only 16 out of 100%, we are giving only 16% of energy to the drive line. So in the drive line, we are making use of some losses of 3% losses and drive line losses. We call it as a drive line losses. And 16 minus 3, we are giving only 13%. So we assume that, even though you're assuming that you're giving 100% of energy to the fuel tank, the possible work, because we want the work to be done, the possible work is only 13%. So this 13% is vehicle related for the clutching, accelerating, and braking that was distributed. Only the 13% is distributed energy. We talk about the percentages given in the form of energy. Okay, so the energy is only 13% is distributed. That is the reason why the vehicle is having the lower mileage of 15 kilometers per 1 liter the mileage because of these kind of losses. Okay, because the engine itself making a big amount of losses. We need some kind of energy to be given to the wheels. Okay, and next one, let us move on to the highway. The highway driving, there is no speed breaker and there is no traffic signals like that. So when you're going to give a 100% of energy to the fuel tank, in the energy, again, there will be engine losses will be there. Standby, there is no losses because we are not going to stand for the speed breaker in the highway. So totally 23% you are giving to the driver line. Again, driver line losses will be 4%. So now earlier, we talked about on 13%. Now in the highway, we are just using 19% for clutch, acceleration, braking to rotate the wheels. This is what happening in the normal IC engine based vehicles. Now we go for the electric vehicle, how the energy saving in the hybrid vehicles. Okay. So here what we are going to do, the standby losses will be eliminated by the micro hybrid because already I said that it is going at the on and off in the standby mode. The hybridization, the micro hybrid will eliminate that particular loss. So there is 8% loss will be eliminated. And next step. So mild hybrid will reduce the losses of the 6%. And the full hybrid, so what you're going to do, we are going to either you downsize the engine or you can able to decouple the engine with a wheel or you replace the engine with the help of a motor. Okay. So even the plug-in, we eliminate the engine entirely. Okay. So full hybrid means we are using both engine and as well as motor, but we are downsizing the engine. So the losses will be reduced, or else we are going for the plug-in vehicle. You eliminate the engine completely. So engine, you put the motor. So now what is happening? You are giving the 100%. This is for the electric vehicle when I'm going for the city driving. Normal city driving, I'm not taking for the highway driving, city driving. I'm giving the power of 100% to the motor. We know that, the efficiency of motor, let us assume that there are 90% efficiency. As per in our laboratory also, we are taking 90%, 80%. So the motor loss will be 10 and we are giving the efficiency of 80%, 90% from the motor. Now, you just assume that this 90% of efficiency are given to the driver line. So obviously there will be some driver line losses will be there. Now, earlier cases we've seen for the plug-in or whatever it may be, the conventional vehicles, we are giving only 13% of energy or 19% of energy to the wheel line. But when you're going for the electric vehicle, we are giving 76% of energy that has been given for the clutch, acceleration, or braking. So this is called as the energy loss calculation. So here we have taken only the ample amount of value to illustrate that how much of energy will be transferred from the battery to things. Okay, so based upon this, we can able to understand how much of the essential things has been done. from one end to another end. But when we're going for the city driving of electric vehicle, we can able to assume that how much of efficient. So this work also the people can able to take and write a paper in this work. You take a realistic electrical vehicle, you take the realistic battery specifications, you take realistic value of the motor, you take the realistic loss calculations. You take realistically, you can mention that for the different electric vehicles, how far you are maintaining the different variety of the energy you're transferring to the transmission line. So this is called as a transmission line. This is a wheel, this is a transmission line. Okay. How much of efficient like that? So n number of papers or n number of projects can be done in this particular electric vehicle. Other than just making a power electronic converters, the economic validation of power electronic converters can also be made. For an example, when you're going for a power electronic converters, when you're having this unregulated DC voltage can be made a regulated by a DC-DC converter. And after DC-DC converter, we can make use of this inverter. And from the inverter, we are going to use the motor. So our power train will be consisting of these power electronic components in order to support between the batteries and the motor. And then we talked about on hybrid electric vehicles. The hybrid electric vehicles, we can able to see some two or more energy conversion or two or more energy storage units, either both the things like engine and as well as the motor. So here, what is the requirement of hybrid electric vehicle? What are the key objectives of hybrid electric vehicle? So I want to maximize the fuel economy, and I want to minimize the fuel emissions. I want to minimize the propulsion system cost to keep the entire system quite affordable. And I want to maintain the acceptable performance with a reasonable cost. And finally, I want to reduce the car weight of the car. This is the core objectives of the hybrid electric vehicle. The hybrid electric vehicle should have the core objectives of this particular thing. So what are the advantages of hybrid electric vehicle? We can able to see that it's having regenerative braking, reduction in the engine vehicle weight, fuel efficiency is increased as shown with help of the loss calculation, and emissions are decreased, and cut emissions of global warming by pollutants, and reduce the dependence on fossil fuels. And some states in India, they offer incentives while going for this hybrid electric vehicle, and it's more efficient, approximately 2 times of more efficient than conventional engines. And we talk about on the list of components for the design of the hybrid electric vehicle. We talk about on powertrain or drivetrain, which consisting of motors or controllers and energy storage systems and hybrid power units and transmission like that. Now, let me talk about on the charging. When we move on to the charging, so this charging can be classified into three types. One is called as the home charging, one is called as a destination charging, one is called as the opportunity charging. Okay, so normally in our house, we are not making the thing of locations because already I've given you the calculation that in which location we have to make the charging. Let me take the first one of the charging as home charging. It is comes under the AC level. So I will tell you AC level will be of the, it depends upon the rating. AC level or DC level. I will tell you the rating. Level 1 means there will be some rating. Level 2 means some rating. For an example, when you take a wind energy power plants, we'll take as a, what is called as the, based upon the size, we talk about on a mega plant or mini plant like that, So you can able to see that, the charging can be classified as a residential charging and fleet charging. So the fleet charging, it is classified as AC level or DC level. And then we could go for the destination charging. That is also a workplace or destinations or corridor charging, and finally the opportunity charging. So this will allows a range of anxiety. So we have to provide the best destinations or locations either alongside over the highway corridors, or the workplace charging will be having some rise and supports of electric vehicle adoption. So there are so many number of ways the electric vehicle can be charged, which can be characterized by the speed of charging. And we have to make sure that what kind of characteristic of a site and typically what is the need of usage is required. So when we talk about on energy storage elements, we talk about only on the lithium-ion battery. There are n number of batteries are available, and also the other energy storage systems called ultra capacitors and or super capacitors or flywheels can also be used. And we talk about on something about in this particular area. These are some of the pictorial representation of the super capacitors. So this energy storage system, predominantly as electrical engineers, we do concentrate only on electrochemical type of charging. But even if you want to write a review paper on that, the complete energy storage system has been classified as when you take a complete chemical, it's hydrogen energy and systematic. It's a storage. Okay. But still there are so much of avenues and opportunities are available for storing the hydrogen. That is what the reason presently our Department of Science and Technology, they have made a call for proposals on hydrogen value call. Okay. That is, it's a very, what are the avenues are available to store the hydrogen? Okay, so once you store the hydrogen, because what is the requirement of a battery? We need an anode and as well as a cathode. Okay, so for anode and cathode, we need a different set of materials. So one such material we can make use of hydrogen. So if that is the case are available, we can make use of this one. This is what the complete electrical, that's a capacitors or the small or medium electronics energy storage, small or medium energy storage. When you go for the mechanical flywheels, it's a quite popular pumped hydro. These are called as the energy storage systems. And the thermal sciences, these are the energy storage system. And we do always follow with the classical batteries or flow batteries. In this, for as far as this electrical vehicle is concerned, we follow this only on the lithium ion battery. In some vehicles, they are using the nickel cadmium or nickel magnesium hydride or sodium sulfate or sodium ion or lithium sulfate or lithium polymer or metal or sodium nickel chloride. Okay, these are the classical batteries. Okay, some of the flow batteries means that is called as something like air batteries, like oxygen oriented, because certain batteries that are readily available that is useful only for the space applications. Space. Okay. So we are taking certain batteries that should be low cost. Even we can able to imagine that the battery that has been useful for the space, we can useful for this electric vehicle also. But the thing is that the cost is much more higher when we consider the battery that has been useful for the space applications. And what are the attributes of the charging? What is the requirement? So the requirement is it has to provide the high peak and high pulse specific power. Okay, that's a normal thing. And high specific energy at pulse power. And also it has to make a high charge to maximize the regenerative braking and long life. This is what the requirement, what we expect from the battery. This is what expectation. But what are the challenges in the battery means we need to provide some appropriate technique to determine the battery state of charge. Okay, this is the first one. What many peoples are working with the determination of the battery state of charge. Okay, they will monitor the voltage or current parameters or temperature parameters, or even with the help of this IoT-based systems, we can able to detect the certain techniques to determine the battery state of charge. This is my area of research where I'm going to develop some abuse tolerant batteries. This is my area of research. Abuse tolerant means if you take a battery, if some fault or some disturbance is occurring for this battery, how these disturbances are tolerated from the battery. Okay, because the batteries are very, very sensitive. Even if you give any kind of disturbance or any kind of imbalance voltage, what is the thing? Okay, and this is a very interesting area. Even the DST, they're calling for this kind of proposals in the waste management technology. They're asking about recyclability of the batteries. So once the battery life is over, or once the cycles of batteries over, how we are going to recycle the batteries for appropriate one. These are the challenges. So whenever we are doing a research in the area of battery or charging, we have to address these challenges. It's having a high scope for available when we answer these particular challenges. So as I already mentioned you, the battery, it will be highly useful whenever we travel with a straight road, but whenever we're going for the initial acceleration or climbing hills, and whenever we're going for the high for the regenerative braking, we can go for ultra capacitors. Ultra capacitors is a combination of both the battery and as well as capacitor. Okay, so capacitor means how we denote the capacitor. It's having two parallel plates, but no chemical is available. But battery, we can able to understand chemical is available. So what they have done, they combine the features of both the things. Capacitors also energy storage and batteries also energy storage. But with adding these two features, we are using the ultra capacitors. So we are going to make it stores energy as electric charge, the liquid layer between the ionic electrolyte and the conducting electrolyte, between as like a two parallel plates. So it behaves as like a capacitor. One plate will be called as ionic electrolyte, and one place will be called as a conducting electrolyte. This will be ionic, this will be conducting, as like a capacitor. Okay. So by this, we can able to start. So there is no chemical substances involved in the ultra capacitors. So this is the one of the ultra capacitors, power catching PC2500 model make ultra capacitors. So this is and even some students are very much interested to work with ultra capacitors for their hardware development and for installations like that. But it's quite costly here. But we should say that, this is not a remedy, or this is not a what is to say, substitute for a battery. This is called as a alternate for, not an alternate for a battery. This will be working with a battery in a complementary way. Like it will be useful for acceleration and climbing in or regenerative braking. And similarly, when you go for one of the mechanical storage element that is called as your okay. Okay, so where we can able to understand that this is the way, that is the flywheel. This is a mechanical energy storage element which stores the kinetic energy based upon the rotation of the spinning wheels. This is what the people even they are doing some projects, So in the highway, when the vehicles are moving, based upon the movement of vehicles, the flywheel will be moving. So that movement we can able to store as a charge. That is the normal nature of a flywheel. So it delivers a smooth flow. So many people are even started to do some kind of works on the flywheel. Okay. So it's consisting of a bearing and motor generator, flywheel rotor, and the magnetic bearing. So based upon the rotation, we are observing the rotation and taking the rotation, and then we can able to store the energy. What is meant by regenerative braking? Regenerative braking means, so whenever the driver is applying a brake, okay, when he's applying the when driver is applying the brake, now the motor will become a generator. Okay, so now the motor is becoming a generator means the kinetic energy that has been generated, it has to store in the battery. So whenever we are stopping, braking means a stopping. Whenever a driver is braking, now the motor should behave as a generator, and whatever the energy that has been delivered with the help of the kinetic energy, it has to be stored in the battery. So the absolute choice of regenerative braking is I want to store the energy in the battery. When we take a Toyota Prius vehicle, it uses about 30% of heat loss kinetic energy from braking. Okay, so the energy can be either stored in the battery or the energy can be wasted in the form of heat. Okay, that's what we normally talk about in the slipover recovery scheme, like a Kramer drive. So in the power electronics, we talk about a Kramer drive, Servius drive. So we can also adopt that kind of methodology also here, how we can able to adopt those heat and convert into a useful thing. For an example, if the 30% of power has been stored usefully and the 70% is dissipating in the form of heat. So instead of dissipating in the form of heat, we can able to adopt some Kramer or Servius drive over here, and we can able to convert the 70% into a useful storage of energy. So hybrid power units, it's consisting of, it's a mechanical oriented injection engines and spark ignition engines, gas turbines and fuel cells, etc. Let us take a one by one of the power units. This is an engine unit. Okay, so it will achieve some combustion through some kind of use of spark plug. So whenever you start the vehicle, we need a spark plug has to be get connected, and this requires some pressure injection, and the throttle and the heat losses will be there, which will also makes the combustion chamber, will increasing the thermal efficiency. And this is called as the spark ignition. It runs on the Otto cycle, where we can able to, before entering the combustion chamber, it makes the air fuel mixture. Air is mixed with the fuel. Okay, so mixture takes place and the chamber will be compressed, and now the spark plug will be ignited. So these are the things when we go for the hybrid vehicle, we have to make use of this kind of engine based substances. Okay, and then the hybrid power units also consisting of gas turbines, which runs on the Brayton cycle and raises the pressure and temperature inlet. So now the air will be moving to the burner, the fuel is injected and combusted to raise the air temperature. So this is one of the ignition units. So completely mechanically oriented. So we don't want to focus on to that. So this is one of the power units. We consider the fuel cell also under the category of a mechanical oriented. So where we can understand that it consisting of anode and cathode. So we normally, this is quite costly here. Okay. We normally take a proton exchange membrane. This will be the atmospheric air. So here the anode and cathode. So here instead of this particular fuel only, we are making use of the hydrogen. We are using the hydrogen instead of fuel. So this anode and cathode will take place, and based upon that, it will generate the electrical input. As like a battery, it's like a battery. It's just like a battery, but the thing is that here we are not making use of chemical substances. Only thing is the requirement is hydrogen. So it will generate the electricity with help of electrochemical reaction by combining this hydrogen along with the iron. Okay, so the thing is that what is the problem when I'm doing with this fuel cell? The problem is I have to make the hydrogen that tank to be safe and secure. And whenever it is fuel is exhausted, I want to say the safety precaution each and every day. So this is a hydrogen-rich gas is very much important. So there are various methods are available even for generation of this hydrogen or production of hydrogen. Our Indian government requires more number of proposals in this area like how we are going to generate the hydrogen. Generating the hydrogen is one point. So what are the methods with the help of electrolysis and even by the pyrolysis? And even we found a method by heating the transformer oil at extra high temperature, we can able to get the hydrogen as a byproduct. We can able to get the hydrogen as a byproduct. But how to storage of hydrogen is a very big question mark. How long you can able to store and how to store and how to make that then how much of hydrogen has been used. So that is a very big important thing. Once we self-sustained with the hydrogen, with the various methods, we don't need to bother about the chemicals. We don't need to bother about the fossil fuels. So the fuel cell will work for the near future. Here, the fuel resembles the hydrogen. And cathode, this will be acting as a anode. Cathode will be like a atmospheric air because we normally I said that anode will take the role of metal and cathode will take the role of a liquid or gaseous. But here we are not using a metal. Instead of that, we are using a hydrogen-rich gas. That is the thing of fuel cell. Now let us assume that transmission. So here the transmission means how the motor is connected to your that's a wheels, it calls as a continuous variable transmission or automatic super variable transmission or manual transmission or automatic transmission with a torque controller. This is one of the transmission part. So which will can able to control the infinite number of variable transmission. Okay. So we cannot be able to compete with a 4 speed or 5 speed, and we can able to make up acceleration and the deceleration. Only few vehicles like Toyota Prius uses these kind of, it's just like we can able to say, we normally call it as a brake. It's not a brake. We normally call it as a gearbox, gear rod. Okay, as like a gear rod transmission. So transmission is directly controlled by a gear rod. So what else you're going first gear, second gear, third gear, fourth and fifth and sixth like that. So vehicle propulsion is required because propulsion means how your vehicle is entitled to start with. So series power assist and parallel range extended and the dual mode is combination of series and parallel. So this is what the series propelling your vehicle. So which consisting of a generator and the power unit and energy storage where we are using a motor and controller and how the transmission line has been used. So we can able to see the direction will be like this. And in the series configuration, we can able to see from the engine, generator, battery, motor, transmission line, and wheels. Okay. And let us see about the parallel configuration where the directions will be on the multiple directions for regenerative options. So when we have the comparison between the series propulsion, the parallel propulsion, so series will be never idles the reducing emission. Okay, but here we are having a more number of power. So it does not need a transmission, but you need a transmission. So power is directly coupled, so it will be more efficient. So power. So whenever you're using a bidirectional flow, it is quite efficient. Now, in most of the electrical vehicle, we talk about on EPA rating. That's economical power rating. Okay, it's by the federal US government has been given this thing. So it shows that what is the drive cycle conditions, drive cycle, whether the vehicle is suited for city driving or highway rating or real world or constant speed, and what's the test temperature, and what's the start condition, warm or cold or fuel, and we have to convert to the gasoline equivalent or test mass. It accounts the how many passengers you can able to carry with and what is the miles per MPG means miles per gallon. We normally call it as a mileage. Mileage only we talk about as a MPG. MPG means miles per gallon. Okay, so in this rating, it will specify that what will be the MPG. That is for 1 liter, how many miles it can able to start with. So this will be the rating which has been sticked by the various cars. So this is one of the MIT electrical vehicle. It has been taken from the MIT.EV electrical vehicle tech EVT. In this link, it has been taken where it has been given the rating about the vehicle. The entire thing of history will be pasted by this EPA rating. So now we can see the current areas of research related to the electrical vehicle. So most of the things we focus the research on maximizing the efficiency. Okay, so in order to increase the efficiency, one thing is we want to reduce the mass or weight of the electrical vehicle, and also we have to reduce the material involved. For an example, we are replacing this engine with a motor, and also the manufacturing costs, and also by the uh, improving the hardware and the battery. Instead of this nickel metal hydride which has been used, we can able to make use of this. Instead of lithium ion, we can also go for this nickel metal hydride, also can be used the current areas of research. Now we can pour some inputs related to the battery topology, because battery plays a very important role in the electrical vehicle. So once after that, we can able to see about the power plants. So now the nickel metal hydride battery, it is having some advantages. It is high energy, like more than lead batteries, which is having a longer cycle and needs no maintenance. These are the benefits of nickel metal hydride battery. Okay. We normally call this. These also can be useful for the electrical vehicle. But the disadvantage is it is heavy and bulky. It's having very high prices. Okay. So when there is a high boom of hybrid cars, there will be some shortage of supply. So the lead acid batteries, this we are not using for the electric vehicle. But the thing is that, it is low cost, specific energy. Specific energy is given by how much of power, this is not power, how much of energy per kilogram. So if you take a battery size, let us say that battery size is 1 kilo, means for 1 kilo, it will give about so 30 watts. So for per kilo, it gives the specific energy of 30 watt hour. And what is the specific energy of petrol? And what is it due to self-start cars in so different years, how the variation of the specific energy has been changed. Now the specific energy has been changed with uh, 201 WH per kg and specific density. So density means, how much of energy per liter of the electrolyte substances, and specific power and prices, and number of cycles means, after it will go across around 1,000 cycles. So these are the batteries used in electric vehicle by the different company and a different country and a different model. So when we are making a comparison between these things, we can able to see most of the countries, they are using the lithium ion to the predominantly whatever we have seen with the high model cars like GM, and we can able BMW or Mitsubishi or Nissan or Tesla. Yeah, all the things. Okay, we are using the lithium ion batteries. But certain other manufacturers, they are also using this nickel magnesium hydride. Okay, so this makes some high amount of cost, and some are even using this lithium ion like that. So the different types of battery. But one thing we have to understand that the role of battery is only a electrochemical energy conversion takes place. So now let me compare this nickel metal hydride and the lithium ion. So because these two only they are using predominantly for electrical vehicles. When we compare to this, lithium ion, normally we know it's used in the laptops and cell phones. Whereas metal hydride is also useful in the computer and also in the medical equipments. The life cycle will be lithium ion will be low, whereas the nickel metal hydride will be larger than that of the lead acid batteries. So the current contribution of the nickel metal hydride is it is used in the hybrid electric vehicles. The challenges of these two batteries will be the nickel metal hydride will be high cost, but this is called acceptable cost, high self discharge. So life cycle, so less life cycle, and the cell and battery safety will be more over here, and it's also abuse tolerant. But here we are able to see the challenges are heat generation, losses of hydrogen, and the low cell efficiency. So, and other factors for the lithium ion will be high specific energy and power, more the things. That is the reason, since it is having both energy and power, we are using the lithium ion, even though, and also another choice is it is on the affordable cost. And it is having the good high temperature performance and ELF discharge and rechargeable parts. And here this lithium metal hydride, it is also abuse tolerant and components are recyclable and reasonable specific energy and power. So we can make use of any one of the batteries and its advantages has been given. Now let us move across to the basic definitions of the battery before we move on to the role of connection of the battery to the power electronics. Okay. So we can able to understand a single cell battery consisting of so many cells will be there. A single cell will be consisting of okay, a single cell will be having the complete battery. So a complete battery will be having a small cells. So these cells will be having the two leads. One is called the anode and cathode. It's a plus and minus. Okay. And also which is be having the other compartments like electrode, separator, and electrolyte. Module means it's a combination of all the individual cells. So few cells are combined. Okay, so these cells are combined with help of welding. We normally make a welding between the two cells. A pack means a pack of battery will be comprising of modules. Okay, so that is whatever the battery which you are seeing. Inside we are seeing the modules which was placed in a single containment. What is meant by AH of a battery? AH of a battery is how much of ampere can be discharged by a fully charged battery. For an example, let me assume that I am taking a 10 AH battery, fully charged battery. AH means, let me assume that I'm making a load of 10 amps of load. So from this particular battery, I can able to deliver a power of 1 hour. Okay. For an example, my load is 5 amps only. So with this fully charged, I can able to deliver a power of 2 hours to that. So it is consisting of ampere and hour. That's called AH. And specific energy means the energy is used to show that, how much of energy, that is a WH per the volume kilogram, how much of energy. Specific power means how much of power, gravimetric power for the given mass of a battery. Energy density means same energy divided by liters, and the power will be power divided by liters. Internal resistance of the battery is very, very important whenever we go for modeling. Okay. Whenever we work with the equivalent resistance within the battery, so the internal resistance will be different for both charging and discharging. This internal resistance can also vary as per the operating conditions. So the peak power of the battery is calculated as per the US Advanced Battery Consortium definition. Peak power is calculated by 2 into open circuit voltage the whole square divided by 9 times of the internal resistance of the battery. This is the definition given by US Advanced Battery Consortium. What is the cutoff voltage? This is a very, very important thing. Cutoff voltage means, for an example, when your battery comes to 0% of charging, in spite of that, you can able to talk or you can able to see a video means we have to see what is the cutoff voltage of a battery. Normally, the cutoff voltage will be defined by the manufacturer. Okay, which we normally relate that to a concept called calibration. For us, it may be a 0%. For the manufacturer, it may be a 2 volt. Okay, so they're keeping a 2 volt as a cutoff, as like a reserve in our vehicle. Okay, so we think that it's a 0%, but it's not zero. Some 2 volt is remaining. Okay, so when you reach a still more to the reserve, then only the problem occurs to the battery. Okay, even at a 0%, for us it is a 0%. For manufacturer, it is not 0%. They're giving a few tolerable voltages that has been indicated in all the batteries. The battery data sheet, they'll be specifying that what is the cutoff voltage. Okay, so it will be interpreted as an empty state of the battery. And then state of charge of a battery can be calculated by the formula. What is the remaining capacity available divided by the rated capacity? For example, the rated capacity of the battery is 40 kWh means, and the remaining capacity is only a 20 kilo kWh means you divide these two, that will be giving you the state of charge. Okay. And depth of discharge will be with the formula. Depth of discharge can be calculated by 1 minus state of charge. So once you calculate the state of charge, you can able to calculate the depth of discharge also. As I already mentioned you, this is my work of research where I'm going to measure the state of health of a battery because the battery will be aged battery. Okay. And when you purchase the battery will be new. Okay. So state of health will be what is the energy capacity of the battery of an aged one? What is the rated? Okay. Because once the battery is getting aged, you cannot be able to meet out its rating. So the formula is what is the age, the energy capacity of the battery divided by rated capacity. By that, we can able to calculate the SOH. And the next definition of the battery is a cycle life. Cycle life is how many charges and discharging cycles the battery can handle. Okay, so certain batteries can handle only a limited cycles. That is 1,000 cycles means it can able to handle only 1,000 cycles of charging and discharging cycles. A cycle means it's combination of both charging and as well as discharging. This is called as a charging cycle. What many people may not be knowing this concept about the charging. We normally say that when the battery is getting charged, whenever you're putting your mobile phone to charge it, we say that your phone is getting charged. But as a technical person, we have to ask the people that whether your battery is charging or charging means which phase of charging. Which phase of charging means that is whether your battery in the bulk or absorption or float. There are having various measuring instruments are available to appropriately calculate if your battery is charged means we have to say at which point the battery is getting charged. So here I have taken the representation of a 12 volt battery. So charging is classified into three. Discharge is different. You forget about discharge. I'm talking about only the charging. Charging is classified into three. One is called bulk, second is called absorption, and third one is called float. And with respect to time, we are going to plot this phasor. This is the voltage and this is the current. When we talk about the bulk stage, let you take a 12 volt battery. During the bulk stage, you see the time period is a very shorter time period. The voltage is increasing and also the current is also tend to increase and the current is maintained constant. That is, a 12 volt battery can even go up to 15 volt. That is the reason when you're doing any projects in a hardware, you measure the battery voltage. You can able to see the battery voltage maybe 15 or even 18. You can ask the question, sir, I'm using only 12 volt battery, but I'm getting 18 volt. No, because the battery is in the bulk stage. Okay, during the bulk state, the voltage will rise gradually and the current, it will draw the maximum current. So what will happen? Your charging will be very much faster in this time period. In during the absorption stage, what is happening? The voltage will be maintained constant. Okay, so depending upon your thing, it even for an hour, it will be constant, and then the current will be declining. Current will be reduced. So your charging will be get much more reduced. Okay, so many people are working with the fast charging. Fast charging means what you have to do, you have to make a technique such a way that to reduce this absorption time. While reducing the absorption time, the total charging time can be reduced. I will tell you what are the methods available to reduce the absorption time. And finally, in the float stage, what is happening? That is, the voltage is lowered, and meanwhile, the current is also lowered. Okay, and it goes for the next cycle. It goes for the next cycle. That is called for the float stage. So, whenever we are doing a research, we have to monitor the bulk and absorption and the float. But in the MATLAB, we cannot be able to monitor, but the real time we can able to monitor. This I can give an example for charging your mobile phone. Let us take that if you're taking a mobile phone, for charging your mobile phone from 0% to let us say 80%, it is charging very fast because it is in the bulk stage. During bulk stage, it is charging very fast. And second one, and later it will be from 80 to 90, you're charging time taken to charge from 80% of your mobile phone to 90%. It not only mobile phone, even your laptop, it is getting lowered because it is an absorption stage. And finally, from 90 to 100, you're taking much more time. This will see, this is the much more time. So in this time, it takes more time to reach from 90 to 100 for completely charge because at that time, your voltage is also in the lower and current is also in the lower. So it takes much more time to charge completion. So whenever we are assessing the charging cycle of a battery, we have to assess how much time taken for bulk, how much time taken for absorption, how much time taken for float. For that, I'm having an instrument called battery gauge. Okay, so that will clearly monitor and say you. Okay, state of charge means it not only measuring the voltage and current. State of charge means with some battery, what it will do, it will remain in the bulk stage for a long time. Some will be in the absorption stage in the long term. So the cycle will not be get continued. That means your complete battery will not be get fully charged because it takes much more time in the absorption. Until or unless you should know what's the starting of this absorption, ending of the absorption. So you should be very ready enough to understand that, okay, absorption is completed. So you can go for the float stage. Okay. After the float stage, you can able to understand your system is completely charged. For charging a completely system, we have to go for bulk absorption stage. Based upon this, we have to go for. So I'm doing some work on microgrid. Okay. So in my microgrid, we are using the battery as a reference. While using the battery as a reference, we should not take just a battery. Okay. So we should not take the battery while taking the battery. We should not take only voltage and current because that's all measurable parameters. We have to take bulk. Okay. Now your battery, the bulk stage. That means it has to cross absorption and float. Okay. Once you measure it, it's in the float stage, means okay. Now your charging is going to complete. You can ask a question. You can ask a question, sir, my battery is 12 volt. Now it is showing 14 volt. Okay, how can I say that it's a bulk or absorption of float? Okay, you can take it may be a bulk or it may be absorption, it may be a float, whatever it may be. But a corresponding thing, we have to understand that what is the regularized image of a charging cycle. So this is the charging profile of a lithium ion battery. So let us say that's a battery voltage and battery current. Here we can able to understand that what is the different stages. This is the pre-charge, constant current charge. This is a CC, is the constant voltage charge or complete charge. Okay. So for charging, we can able to understand it undergoes the region of bulk and absorption and float. Now the charge is completed. So your charge is completed from 0 to 1. And then for the again, if you're going for the recharge, that means you are consumed with this amount of charge. Again, you're going for recharge means it is a recharge and then complete the charge. And each and every phases, we are going to monitor the different variety of the charging and discharging phases. Now let us see about the EV charging schemes. Okay, so we can able to understand that EV charging schemes, we can able to take about the EV from the electrical utility. Utility means it is called a service provider. Even you can take it as a utility as a SP, service provider. So from that, we are given the service equipment and then we are having the connector. So the total complete electrical transfer system consisting of, as I already mentioned you, each and every vehicle will be having a AC charge point, DC charge point, and battery charge interfaces. And then we are having the power electronics and the motor controller, the electric drive and motor. And finally, we are having a battery. So the complete thing, the powertrain remains the same. So the AC part will stop up to here, and after that, our DC electrical energy will go because we are generating and transmitting and distributing electrical energy, yeah, only in the AC. So we have to transmit the thing with the AC. But as far the EV is concerned, we are, once it moves toward the charging point, it will be called as a DC electrical energy. Now the charging level, as I already mentioned you, the level one charging means the typical charging power will be 1.5 kilowatt to 3 kilowatt. Charge level 2 means 10 to 20 kilowatt. Level 3 means 40 kilowatt and more than that. Okay. So these are the different levels of charging. So whenever your car is applicable for a certain levels, we have to design. For an example, if you're designing a project for an electric vehicle means you have to clearly specify that for which level you are going to design. For you're going to design a charging pole means for which pole or which charging you're going to design. So that is the thing. Now we move on to the grid, a grid-based electrical vehicle. So the connection may be from either you can able to transfer the vehicle is can be connected to grid or grid can be connected to vehicle. So based upon that, I will show the symbolic diagram for the grid technology. The benefits will be reactive power support and active power regulation, load balancing, valley filling. Valley filling means that is how to fill up this valley, and this is a very important research area. It's not saving, it's called shaving. Okay, peak load shaving. It's a very important research area. Okay, how to shave the shape it, the peak loads. It's not saving, it's shaving. Okay, and then we'll focus on harmonic filtering. And this challenges of a vehicle to grid is geographical location. And then how many electric vehicles are given in the vicinity? What is the levels of current, voltage, and current? And what is the status and capacity? What's the duration of charge? And what are the charging techniques? What's the charging time? Okay, because the charging time when you're going to the grid, the nighttime charging is having a minimum impact. So what's the time? So these are the challenges. And then this is a simplified architecture of a vehicle to grid. Okay, or let us take that I will show from grid to vehicle. Let us say that what is meant by a grid? A grid, you could take it as a point. You can take it as a point where the number of electrical energy forces is connected to the point. Let us say that this is called as a generators, a generation. And then from this point, I'm going to transmit. So this is a point or a node or a notation. We call it as a grid. A grid is a point or a grid is a line. Okay. And while this grid is very, very adamant in nature. So because whenever what the input we are feeding to the grid, it has to satisfy the norms of the grid or code, grid codes. Okay, so now let us assume that we are having the multiple energy sources. After the conversion, we are going to get the transmission line, and then it's charging locations. We are abrupt charging locations, and from that, from we can able to understand that grid to vehicle. The grid power is given to the smart meter. It will measure how much of power is delivered in and how much of power, and we are having the socket to charge it. Okay, so here we specify the level one, level two charging. Okay, as I already mentioned you that what is a range of level one and level two. And here we can able to give the power has been given to the AC. Now it is given to AC to DC converter, and then we can able to understand about the power factor controller or we can able to understand that the passive filter components we are using to filter out the ripples, and then DC to DC converter to make the this is called as the onboard or offboard battery charger. So our battery charger circuit will be compressing of AC to DC converter. Okay, for an example, because we are charging from AC to DC charging converter, and then the ripple reduction circuit, and then we are going to give a DC to DC converter. So this will form a DC bus. So this is called as a battery charger. If you want to, even in our mobile phone, we are getting the same circuit only. We are converting from AC to DC. So once after the DC bus, we are going to give to the conversion of the DC to AC. Okay, same the DC bus is also connected to the energy bank. We are using the bidirectional DC to DC converter where the power will be transferred over here in the both the direction for charging the battery. Or the from here we can able to take the DC to DC for giving the power to lights, air, heater, or auxiliary substances or audio systems that has been available in the electrical vehicle to that. And finally, this AC power we are giving to this electrical motor and it has been given to the transmission line. Okay, so we are giving the sufficient torque and the speed, the radians per second. There's a differential and it's been connected to the wheel. So this is the overall thing. The role of power electronics is comprises of only over here, the rectifier and then chopper, and then we are having an inverter and a chopper and gear own chopper. These are the converters. And for this, we can able to give a appropriate switching pulse. Presently, I'm writing a book for Wiley. Its book is on pulse width modulation. So we are going to deal with the different types of pulse width modulation for all the power electronic converters. We are going to dealing with. So this is the plug-in hybrid electric vehicle thing. So the components, we can able to see the energy resources and the system operator, charging stations, communication, smart metering, and battery management system. And the power flow will be, if you're taking unidirectional power flow, there will be some reactive power and the dynamic adjustment. There is no specific hardware and cost is less and the risk is less for unidirectional. But the bidirectional means we can go, the converters can flow the power flow in both the directions, both charging and discharging takes place. Bidirectional flow can also make the battery to get degrade and will be giving some additional cost for communication, metering, and interfacing, and which is not available with the present electric vehicles. And let us see about the impact on grid. When you talk about on grid, okay, so there are two different types of charging. One is called uncoordinated, and the next one is called the coordinated. When we talk about on the uncoordinated, it is called as a level one. Level one means in home that is a maximum of 3 kilowatt in home. Okay, so it will increase the load at peak hours, and we can able to see 260 watts per electric vehicle off peak charging. When you go for the coordinated charging, it can be able to optimize the time and power demand. It will reduce the electricity cost. It is more suitable for the higher levels like level 2 and level 3 and decentralized and also centralized. And we can able to make use of the renewable energy at the maximum. So aggregators, it will be like a controllers and monitors, which will monitor our pricing and the SOC of the battery and the location. It becomes a contact between the electric vehicle owners, and these aggregators can buy the electrical energy. It's just like a moderators. Okay, they will oversee how much of power flow is being there, and they can buy and purchase to make this particular market in the retail. Okay, the technology challenges is about the charging. We can go for the smart charging or smart metering, communication control, or aggregation. That's a distributed energy resources and spinning resources, and battery degradation. That's one of the challenge and effect on distribution equipments. And we can go across the investment cost and energy losses. So these are some of the environmental challenges. I'm not quite skipping. I will share the presentation. I will skip this thing. The environmental challenges and the hybrid electric vehicle challenges and safety. Safety is very, very important because I work mostly on safety of electric vehicles, because normally the converters are already been there. So I work mostly on the safety. So inertia switch to deactivate the contactors. And what are the batteries? The batteries should not make any kind of spillage, like if there any kind of leakage, and service disconnect for the big circuit breakers, and a few fuses. Of course, we need to go for the fuses as well, and we can able to isolate the frame when you go for the traction pack, and the load rating recommended for the battery boxes. Again, the rating, the recommended rating when you go for the battery banks or battery boxes. And we talk about on performance. So the acceleration, the speed performance should be as like an internal combustion engine. And ranges starts from economic car to the muscle car. Muscle car means the very big car, okay, like a Grand Vitara, something like a very big Tesla, like that. And the DC motors great for drag racing. And the current research says that the records about 8.801 seconds and the 1/4 mile by the current eliminated the performance. And the range will be typically of 30 to 60 miles, and over 100 miles can be attainable by using some advanced batteries. So the common claim is electrical vehicle is just to move the pollution. Okay, so the takeaway message is the emissions can be go across. So emissions with the help of this diesel and also the electric and also the savings, you can able to say that the savings of electrical vehicle is much more higher when compared to the other kind of things. So benefits, I skip. And this is what one of the other research area on the meeting the challenges about the battery swapping. Okay, so it is about how we are interchanging the charged battery with the uncharged battery with the recharged one. Battery swapping and the rapid swapping, and we'll talk about. So these are some of the electrical vehicles that has been emerging today, a model of various kind of things, which makes a top speed of this a Tesla motors, a top speed of 125 miles per hour, and the range and the prices you can able to see it's a 1,10,000 US dollars. Okay, so 1,10,000 US dollars. Okay, so you can able to see that it most goes more around near to the 1 crore, and Fisher Karma and Tesla model, and then Chevrolet Volt. Okay, these are some of the available soon vehicles. Think City, Nissan Leaf, Aptra 2E. Okay, these are some of the companies that has been in the pipeline. So electric vehicle charging, this we have already discussed about the level one, level two, level three. And AC charging means we can able to go with the home or fleet or public use. And DC will be like a large fleet use depending upon the ranges. And this is a final thing about the common myth, what we have to say that. So plug-in vehicles are useful only for short trips. Okay. And these electric vehicles are not useful for going to college and coming back. Okay, this is a myth, but the fact is, so the average is 40 miles or less. The most of full battery electric vehicles are targeting. Now it's going to target, so we can able to go with even 300 miles or more. It not only useful for short trips, it can be also useful for more than 300 miles. And we talk about a plug-in vehicles are not clean because from the power plant only we are going to give whether it is clean. So what we are going to answer is we are going to make it as a clean with help of some using some renewable energy integration and make it as a clean. And that's a second myth. And the third myth will be it makes your electrical energy to build to go up. Obviously, because it can be able to make the electrical energy, because for 1 unit we are spending about 8 rupees, or we are going to make it about more than 12 rupees. Okay, so we can able to make use of this integration of renewable energy to reduce the time, and it's far more expensive. Yes, it is expensive only than that of the average car. So the conclusion of my presentation will be we can able to do some challenge to power systems and the battery banks and the battery management systems, and several intelligent control modules can be used for the integration of battery to improve the life performance and also the overall performance. And the takeaway message of the today things will be the power electronics. Okay, it being the technology for converting the electrical power, it makes a very important thing in the model electrical energy, and this has been the essential part for the integration of systems and the power systems, and the smart grid and the microgrid and the distribution grid. So these are the step-by-step things our development has been moving across. Okay, so and exactly I completed by 11:35. Now it is open for the questions. So now let's move for the questions. If you have any questions or any suggestions or any comments, we can discuss. Hello? Hello, sir.
Thank you very much, sir, for your valuable session on behalf of Department of EEE and VVIT.
Is there any questions? Even you can put in the chat box. Okay, if there is no questions, I may leave. Thank you so much for the opportunity given. Thank you all. Isaac, sir. Hello.
Hello.
Yes. Hello.
Sir, thank you, sir. Thank you for your session, sir.
Thank you, sir. Thank you, sir. Thank you.
Yes,
Can I leave, sir?
yes, sir. Sure, sir. Thank you, sir.
The next session will start at 1:30 p.m. Thank you. Let us end the session.